Good evening, everyone, and welcome to the 29th public lecture hosted by NUS Cities. Before we start, please ensure your devices are on silent mode. For those who are new to NUS Cities, we are a university-wide, interdisciplinary, and inclusive platform hosted within the College of Design and Engineering. Through our collaborations with local and international institutions, we hope to create synergies that extend within as well as beyond NUS. We are pleased to host this evening's session with the Design and Planning Lab at the Urban Redevelopment Authority, URA. Designated as the Urban Planning and Design Center of Excellence, also known as URBEX. URA aims to build up strategic science, technology, and engineering capabilities to advance the planning sector in Singapore. URBEX drives innovation, encourages experimentation, and sharing of lessons through collaborations with partners and organizations. Bringing these strengths together, tonight's lecture is a collaboration between the NUS Cities Lecture Series and URA's Design and Planning Lab. Both share similar spirits, exploring ideas for sustainable, resilient, and livable cities, while fostering cross-sector exchange on urban planning through topics such as transport modeling, AI, data analytics, VR and AR, and future urban challenges. Through this, we hope to create a space for conversation to give momentum to ongoing research and exploration regarding issues concerning cities. I would now like to introduce our speaker of the evening. Prof. Luís Bettencourt is a professor of ecology and evolution at the University of Chicago. He also serves as associate faculty in the Department of Sociology and as an external professor at Santa Fe Institute. His research focuses on the theory and modeling of complex systems, especially the structure and growth of cities. He connects mathematics, technology, and data to urban growth and sustainability, and collaborates with governments, NGOs, and global researchers to co-produce new insight. His work is widely cited in academia and covered in the media, helping to shape the global discourse on urbanization and sustainability. Please join me in welcoming him on stage.
Hello, everyone. I have to turn the... How do I sound? Got it? Great. So it's a great pleasure to be here. It's always a pleasure to visit Singapore. I thought since this is a public lecture, I'm not going to tell you a lot about papers and graphs. I'll have a few just to keep it real. But I want to get to some fundamental questions about, that's why the title is so funky, why cities, why science? And maybe it's obvious. I really mean why use science to think about cities, to think about human societies. But, when you're a scientist, you ask very simple questions like these questions. And that's kind of, if you start asking a lot of questions about human societies, like where does economic growth come from? Is inequality unavoidable? Can we make our society sustainable? What is development? We actually don't know. We do it, we push for it. You have an experience that's extraordinary here in Singapore, but we've not had good explanations about these phenomena. They're so fundamental. And what has happened in the last 20 years is something very important, which is that we've started to understand these processes by looking at cities, by looking at urbanization happening. And this is mostly because of Asia. Because in Asia, not just in Singapore and Hong Kong, which were pioneers, but South Korea, of course, Japan before them, and now China, urbanization has happened very quickly in one generation. And with that, we also saw societies going from being very poor and basic to being very sophisticated and rich. And so this is a place where you've lived all this through in a generation, if not you, your parents. And again, we live it, we try to make it work, but we don't understand it. And the big challenge looking forward is that we think about the remaining parts of the world that are also urbanizing quickly, particularly in South Asia, Southeast Asia, and Africa, that we are asking to urbanize also in one generation or less, but sustainably, so even differently from what you've done. So part of what the background to this lecture is the fact that we're starting to understand these processes scientifically. It takes looking at cities, and I'm going to show you a little bit how. But I'm also going to ask you lots of questions just to make you see that there are many things we don't know and that you must know if you want to think of the world through cities. Okay, so this one everyone has seen. It's a very famous sort of diagram. Everyone says this. The world's been urbanizing. The year at which the world's supposed to have become more than 50% urbanized was 2007. And in 2000, and at that time, the big change was mostly because of China, because so many people started living in cities, right? 1.4 billion people. And that transformation, changed China, changed Asia, and changed the world. But this is happening a little bit everywhere, right? And as you can see, the slide is a quote from a UN report. It says a couple of things that are quite deep. One is that urbanization is shaping our planet and is leading to global economic development. You know that. But that last quote, besides some of the numbers, the urbanization only occupies less than 2% of the land area of the world. So it's very tiny in terms of land use. Of course, has other consequences. But this movement has lifted more people out of poverty than any movement in history. We've never had anything like this. That you go from quite extreme poverty and low urbanization, like in China in 1980, not that long ago, 20% urbanized, more or less, to what it is now. It's an extraordinary thing. It never happens without cities. Never. There's no nation who's rich, whose people live long lives, the societies that know how to do many different things, which is not an urban society. So this has been a puzzle, and it's a realization that we just came to terms with, just by observing it, by feeling it, but now by also thinking about it scientifically. So this will be most of my point. But before I get to that point and show you more things, I want to kind of shift the point of view. So this is a point of view from media studies, and you might have seen this quote, it's very famous. It's from maybe the most famous writer in media studies called Marshall McLuhan. And his point is that the fish are actually the worst creatures to ask about water. They know nothing about water because they live in water. It's normal. It's their universe, right? So they don't have perspective. They can't tell what water is about. So since, then he uses fancy words, since they have no anti-environment, they have no comparison that would enable them to perceive the element they live in. And in some sense, this has been true about people, right? Particularly people in the 21st century. We live in cities. We just take this for granted. It looks like a bunch of problems and messy things, and that's the way we approach it. But think about, so what I want to do with this lecture, in some sense, is take you a little bit back and make you think about what it is that cities are. And in some sense, this is a photo from Singapore. Hopefully I got it right. But it's kind of this sense that we just approach this as being normal. What's happening is not normal. It requires an explanation. That's what science is for. But also, once you have a better explanation, opens up many different ways of thinking that we've not used because we approach a lot of the issues of cities very practically with our noses to the ground. So before I do that, again, I'm trying to set up some perspective. I want to set up sort of a thought experiment. Okay, so you know about thought experiments, I think. It's very famous in science. For example, Einstein was a master of thought experiments. What would happen if you would ride like a light beam? How would you see the world? Time would stop, for example. This is different. I want to drop you in the middle of nowhere where there are no people. You could even choose where it is, but there are no people around you. And I bet you that you die pretty quickly. I'll give you a few days. It doesn't matter if it's very cold or very hot, etc. Because humans are bad at surviving by themselves. We actually evolved not to do that. We're very strange creatures. But if I dropped you in a city, doesn't matter which city, here's a city, right? You probably can't guess what the city is. That's why I picked a weird one. It's an obscure city. It's an old city, but it's an obscure one. You would know exactly what to do, even if you don't know the language. If it's not a city you would know, that there are buildings and there are streets. You can walk around. You know that there will be people, that there's food around because all these people are around. There's water. You'd have to negotiate with the locals, but they know what you need because they need the same things. There'll be rules. There'll be ways of finding. There'll be some authorities and governments, all these things. Doesn't matter which city it is. From the very first city, almost, 6 or maybe 8,000 years ago, to the cities of the future, to every city in every continent, to every economic system, to every political system, they work the same way. You'd have to know what the political system is. You still get food and get by and so on. So imagine what I just said. I just said that cities are more important, more fundamental to human societies than political systems. You know, there have been communist cities, there have been capitalist cities, there have been cities with systems we don't have names for. Then political systems, you know. There are all kinds of political systems that have cities. Then culture, then food, you know. Then any of these things that are so fundamental about humans, you can have cities in all these forms. So it's a very, very fundamental thing that we haven't understood yet. I hope to convince you of that. You don't seem very convinced as I look at you. But I want to shift your perspective. This is not, it's quite important. So I'll ask you in a moment why this is. But, you know, so this point I already made. There are many things about cities that all urban people get. This is to say that if you grew up in a rural area and you've never seen a city, you may not know these things. You may think that what you have to do is grow your own vegetables and so on. And maybe you, as a rural person, has a better chance of surviving in the wild. But if it's a different environment, you don't know how to farm or to get food, and you have to wait too long, you also won't do well. So there are all these things. There's the built environment, buildings, streets, pipes, public spaces. For many of you who are architects and designers, this tends to be important. But then there are social interactions, there's specialization, that people have different jobs, there's trade, they trade with each other, they're organized sometimes. And then there's culture, laws, symbols, innovation. I'll come back to this. And it is the basis for this, that because there are many things that are common to all cities, these communalities, these generalities tell you that there should be a science. There should be a general set of facts, a general set of things, a general set of processes that describe what a city is. Okay, this is a very pedestrian point, but this is why you can have a science. If everything was different everywhere, then you couldn't, right? Okay. And so the why science, I'll return to cities and their fundamental nature in a moment. But I want first to make a point about why science. You know, so what is science? I deal a lot with, you know, we've had this conversation this morning and so on with people at NUS. Science is not a set of methods. It's not a set of tools. It's really a collection of general facts about a phenomenon, in this case about cities. So we should be able to talk about laws of cities, things that are general, that happen in every city. So I'll show you about that in a moment. This is connected to tools. There are ways of showing how these laws work, so that's important, but in context. And then most importantly, science is always an explanation, okay? It's an explanation about how things work, right? And work that way and not a different way. And with good explanations, as science gets stronger, you should be able to predict many things from relatively simple explanations, right? So I should be able to tell you a few things about cities I already did, and then be able to use that to predict lots of different things. And that's, I'm going to show you a little bit, since it's a public lecture, I cannot do a lot, but I'll show you a little bit about some surprising things that come out of thinking this way as some fundamental things about cities. So the science really, this idea of an explanation that makes many different predictions, and that the point, what I wrote there in red is very important. It's a framework for imagination and for problem solving to do things that we've not done before. That will be the end of my talk today. Is very important, because once you have this kind of knowledge that science gives you, you should be able to reimagine solutions in in ways that are unintuitive. They don't have rules of thumb. They're kind of unexpected. So I'll give you an example. So also I put here a caveat, science is never done. You're always improving that knowledge, right? It's typical. But let me start with an example that we all know about, and our friend Sasha was talking about this week. But it's, so you know what this is, the moon, right? And I think it's fair to say that humans also, you know, humans always wanted to go to the moon. They wanted to know what that was, if they could go there, you know, and so on. Many cultures have lots of stories about that, and legends and so on. But, you know, about, 55 years ago, so we did go to the moon. So how did we go to the moon? You think, well, we got on a rocket, sent some people, we experiment a little bit, we got there. But, you know, a lot of people think, and when you see the movies, it feels like this, that you have a rocket, we're here, you point it at the moon, and it gets there, right? Is that the way it works? If you do a calculation, many of you would be engineers, you would know that it takes a huge rocket to just go in a straight line, you know, go across the potential well of the Earth and get there in one shot. That's not what we did at all. We got there, With a small rocket, little rocket, but big science, we understood a lot of things that are unintuitive. You know this, but look at the orbits. So we didn't send the rocket forward. You can see there, more or less, here's the Earth. We launched from here. We send it backwards. Why did we send it backwards? Because we understand the gravity of the Earth. And we could use it to catapult the thing after it goes a few times around with a little bit of thrust just at the right time to send you towards the moon. And then we do the same thing on the moon too. We go around and we kind of fall into it. And then you have to do the same thing again. This is completely unintuitive. It's because you understand the laws of motion, laws of gravity, that you do something that's not intuitive at all. It's kind of backwards. Okay? This is the power of science, is to think about new ways of doing things. This is just a well-known example, but when you think about it, this is the kind of thing you want to think about, right? Okay, so that's just, okay. So when you think about cities, and I'll be using this theme as well. I'm sorry, my computer broke down, so I have a little bit too many slides. So I'm weaving together a bunch of themes, and I hope they make sense. When you look about cities, there are also two kinds of things. This is kind of interesting to think about, because if you miss that there are two kinds of things, particularly these two kinds of things, you will get the wrong impression. So one of the things, I'm going to call them homeostatic, but they're just the things that happen every day and that make life possible, okay? That's what I mean. Homeostasis of the body is just all the regulatory processes that keep you going. So these have to do with the organization and maintenance, and we often think that actually the work of city governments is to keep all these things going, the water running, the power going, the trash collected, et cetera, the parks trimmed. But there are also a lot of things that I like to call informational. They're about creating organizations, they're about solving problems, and they're mostly about change and transformation. And I just told you in my first few words this evening that cities are transforming the world. So this is very important. It's this second part, actually, that allows you to go from a very simple city to a more complicated city, to people living in different ways and so on. Okay, so with all this is more or less my first third of the talk. I want to ask you a question. Why do cities exist? Now, if I got, $100 by every plan, and I'm not saying here, but I'm just saying elsewhere, all the planners I talk to that cannot answer this question, I'd be a rich man. You shouldn't be able to be a planner, or maybe an architect, or a designer, or a student of cities if you can't answer this. No, this is the kind of question the science asks. It's a why question, not a how question. Okay, so do you know the answer? People is part of it. Here we have people, it's part of a city, that's important. But it's not just about people, right? It's about people doing things together, right? Yes, go on. That's important. Yes. That's very good. So this is now an effective interaction of people. But there are other things also that happen. So this is all part of the answer, you're right. It's about the interactions between people and the potential that these interactions create, right? And the potential, so you all know that, that's my point about dropping you in a city. They don't do anything in a city except through other people. You cannot grow your own vegetables and wait, right? You need to negotiate with other people for space, for everything that happens. And this means that everything is organized, socially, economically, through space, through government, such that life becomes possible. In fact, life becomes better. And what is extraordinary, and I'll show you from data, is that when we do this in a way that's like a city, not like a company, not like a government, not like even a family, then this capacity to invent things, to benefit from economies of scale, but also from other effects that we call, increasing returns to scale, which are effects of information, then these become open-ended. They have no limit. They have a limit within the organization of a system, but they become open. So they don't have a stop. And that's amazing. I'll show you that. Okay, so other questions are interesting too, like, other why questions. What will cities look like in the future? Of course, I'll get back to that towards the end of the lecture a little bit. And this one is also important. Why would anyone want to live surrounded by millions of people with cars and noise and congestion and so on? I mean, really, when you talk to most planners or most people that have comment on cities, they say, oh, cities are terrible. There's congestion. It's so expensive, right? It's expensive. You have all these people up on your grill and you know, I wish I was in nature. But then when you go to nature, as happened in COVID, people get bored, and they get depressed, and so on. Okay. So we really are social creatures, and our sociality, human sociality, is immensely powerful. It's already changed the world, but it's now changing the world much faster because of this mode of organization. That's the point. Okay, so I'll go a little bit more quickly through this. It's not because of master planning. It's not just because of jobs. In many cities around the world, not just think about Singapore or rich cities, people don't have a job when they show up, right? They just have to improvise a way of existing. Shopping is nice, but it's not just because of shopping, right? I had to try to fix my computer in Orchard Road, nightmare. And you know, it's partly to do with culture, but all these things are right, but none of them is sufficient. It's all this plus many things that are not even in this slide. Nice people, bad people. Okay, so this is a nice quote just to finish this cycle. It's from a writer that writes for the Guardian newspaper. This is an article in the Guardian. She's very, you know, I like a lot of her writing, but you see what it says. Basically, of course, people don't come to cities for jobs alone. People come to places like New York and London and Singapore to be around other people. They come for the addictive energy that you get only in places when millions of dreams are crammed together. So this is sort of a metaphorical idea of what innovation is, all the aspirations, all the ideas, and how these generate new things, you know? And, you know, as she says, also many of us, misfits and minorities, stay in cities because the only place we can find themselves. Isn't that extraordinary? That you go to the middle of people, middle of millions of people to become more yourself? So this is very specific to people, and in fact to creatures that can change and adapt and pursue, you know, pursue their interests, pursue their passions, and in that process change. They change because there are things around them that allow you to not do all those other things and become a better writer, a better musician, a better scientist, because that somehow is supported. I mean, this is extraordinary, but it's also a characteristic of a complex system. You can specialize only if all the functions that you're not doing anymore can be taken up by the rest of the system, and everyone's doing what they do a little bit better because they're more specialized, but they become more interdependent. So in some sense, what she's saying, there are many quotes like this. There's a famous one by Martin Luther King, that, you know, you can become more yourself if you're in an environment where everyone can be more themselves, and we can kind of basically, isn't that beautiful? So this is what can happen in a good city. It doesn't always happen, but it's a beautiful thing. And isn't it extraordinary, by that happening, makes also a better society. And a society has more capacity and has more knowledge and has more art and has more science and has more engineering and so on. So this is really the process of cities. But I want to convince you that this is not just talk. And there are a lot of things that we understand in terms of what is general about cities. So I'm going to take, in some sense, a step back. And this is the part when I'm going to show you a few results and some graphs and so on. And I'll show you what they mean. Okay, so I'm going to speak about, so remember when I talk about science, so there are a bunch of facts. These are, I'm going to call it the laws of cities. And there are a bunch of things that are informational. They have to do with, which are also related to laws of cities, but they have a different character. So this is kind of a very crammed slide about sort of a laundry list of many of the facts we know about cities. These are not that cities are livable or they're sustainable or anything. These are just things we observe. They're constant in data. So a lot of my work that really allowed me to pursue this has to do with this idea of scaling laws. They're basically expressing economies of scale. The economies of scale of cities are mostly expressed in terms of space and infrastructure. Then more people can use the same space and infrastructure and service. So you can service more people that way. These usually are expressed as some kind of spatial densification on infrastructure. So one of them, so that's the second line. But then there's also this effect that people can access more people. Social networks get larger. This means you can interact with more and more diverse people. You know, if you dump you on Orchard Road, you know that. And then, you know, that allows you to do the things we already discussed. And these are called increasing returns to scale, but also sometimes agglomeration effects if the quantity is economic. But this also works for innovation. So the result of this are many things that are predictable. That cities become more congested because of the density effect. So you save something, but the movement becomes more congested. You get building heights because you need to create more space that have to do with basically how money and ideas are crammed into space. You need to create more space per unit area. Housing prices go up, but can be regulated through this, but innovation rates also go up because there's more opportunity for ideas and recombination. I'll show you some of this in a moment. Then there are a bunch of other things. Neighborhoods tend to be different from each other. So people still, despite the benefits of mixing, people at home in their daily lives at night, they tend to basically cluster with people that are more like them. So there's both effects pushing for mixing to be creative and an economic creature, but at the same time creating sort of old cultural patterns and that preservation and so on, like Chinatown or Little India, right? Where people still are more or less, the old way. So it's this mixture that's very interesting. And then things like laws of geography that have to do with the fact that cities have many different sizes and so on, and laws of development, which are newer, and we're starting to understand, which have to do with what I started telling you, that for societies to develop, they also need to urbanize. So in some sense, urbanization is the structural transformation of development. So when we look at data, we see things a bit like this. So these are some of these scaling laws. And these have been, I'm showing you, to my knowledge, some of the oldest papers that had identified this effect. So this is an effect from an economist, an industrial economist, this guy's Vaitskakis, and he looked at American cities when they still had manufacturing, and he found that when a city doubles in size, its economic productivity, which is the profits of companies, per capita, they increase by about 15%. And this is another result. So this is not always good, right? When people interact, you also get conflict. So you also find this when a city doubles in size, per capita violent crime. This is American cities again, but this is actually also, Singapore, we don't have a structure, but even in Japan, this happens, but the baseline is much lower. There's much less crime in Japan than the United States, but when you look at Tokyo, there's a lot more than in a small city. So this is basically effects of interaction. And when you look at this in terms of data, these are the famous scaling laws and so on. I'm not going to elaborate this a lot. We do this in a log scale of population and the various quantities. For example, you see GDP. These are all European cities. It means that the GDP increases with population by this effect of about 0.16, 16%. That's the 1/6. And then you see other quantities like urbanized area. The yellow lines are what is expected. Employment is linear, so everyone more or less needs a job, or at least a job per family. And then patents are innovation rates. The way of measuring is not very good, but you tend to see the same effect. It goes like 1/6. This is China. We've written a lot of papers now about China. China has the same effects. The data is a little noisier. In the beginning, it's probably because the data in China was collected in funky ways. But we have a new paper now that was just accepted that shows a little bit more detail with better data. But you find the same effects. It's GDP and area and so on. And so we've done this for a lot of different contexts, including through history. So for example, I'll show you more in a moment, but many countries, you see that the list, this is unreadable, I understand, but this is just tell you that this happens in many different countries, basically every country we can measure. But we also looked at this through history. So for example, I'm about to show you, we looked at the Aztecs, which is crazy, right? We looked at the Romans and so on. I'll show you more. But this also, like any bit of science, it breaks down when the conditions are not satisfied. So it breaks down for hunter-gatherers, people who hunter-gatherers who not settled, did not have cities. And in fact, worked in a different way. They have a lot of conflict, and they mediate that conflict not by solving problems and having private spaces, but by walking away. So those societies have a lot of, periodic agglomeration, de-agglomeration. It doesn't happen in slums where often the infrastructure networks are not there. So these are like bits of cities that are coming along, but they're not often served. I'll show you about that. And this is a new area. It often doesn't work very well in shrinking cities, cities that have too much infrastructure, but where population's leaving. They have, so this, there you have, so this happens when the economy or the reason to be there goes away. Okay. So I want to just tell you a little bit how this works as science. I'm not going to show you the mathematical models, but I'll show you the pictures that go with it, which is how does this work? So this is, again, the same thing for the United States, for roads and for GDP. But there's this effect, essentially, that the economies of scale, which are these, when this grows slower, so the amount of road area goes slower than population. So this is an economy of scale. And the increasing returns to scale in socioeconomic interactions is this value. They both go by about 15, 16%, but one is negative and the other one's positive. So this suggests that's the same effect that's mediating, at least in large scale, what's going on. So this is about explanation. So let me just tell you the nature of the explanation. When you look at a city, this is a famous photo actually from Mumbai. I like this photo because it shows a little bit of, it's a little pixelated, I'm sorry, but it's a train station in Mumbai. You see the trains, you see the tracks, but you see this blur, right? The blur is people, right? So people are moving fast in this background of infrastructure. And so there are two networks here. There's the network of infrastructure, literally here a network in terms of railways and so on, but also think about streets and pipes and other things. They're all networks. And then there's the network of people interacting with each other, which is not a real network like this here. We don't have a thread between us. We actually just end up in the same space, and our behavior is kind of coordinated, right? I see you nodding when I'm talking at you and looking at you. So our behavior becomes coordinated, and this is sort of an informational effect. I mean, there's a little bit of sound wave and so on, but this is kind of just the coordination of information and so on. So these two things, so the social network is basically being constituted by the movement and the encounters of people in space. So you have a network basically of people, right? But then this network needs to be put in space. So this is my bed drawing for what a city may look like. These are blocks and streets and so on. So she lives somewhere, right? She has a little house maybe, and she goes out every day. She meets people, whatever. Every day a little different. And then let's say she comes back home at night, and most people do something like this with variation every day. And as she goes along, she catches a disease, or maybe she goes to the doctor. She finds somebody she loves. She makes some money. She learns something. She has some fun. She eats and goes to groceries. She gets services. So this is happening every day, but it's happening through the encounters that people have. And then when you go to a larger city, the house gets a little smaller. The roads get a little bit bigger. This is all actually mathematical. I'm just showing you sort of the picture. But then with the same, because there are more people in this background, you get more interactions with the same distance. So basically your interaction rates go up, and so the flow of all these things per unit time is faster. So there's both a spatial compression and a temporal acceleration that go together. So this is why basically this is happening. There's another system, if you think this is weird, so this is more or less that. If you think this is weird, there's even physical systems that do something similar, but in a limited way. And the best sort of parallel, even though the numbers are different, the qualitative effect is the same, is a star. A star has an attractive force, which is different, but brings all the matter together. And then when the matter is dense enough, because of interactions between that matter, there are reactions, and those reactions create products, light and neutrinos, and the star shines, right? And a star basically burns faster and has faster processes the more massive it is. It's called the luminosity mass law. It's very similar. So it's basically driven when interactions are driven by density. And basically there's a sort of a equilibrium between the spatial structure and the interaction rate. So this is not like something unthinkable. It just happens by different means, but it happens also between people. The difference is that because people can adapt and learn different things, the interaction potential and the kind of interactions and things we can go together is much more open-ended than between matter and nuclear chemistry. So, but this kind of thing leads to many predictions. Some of them obviously are pretty close to what I showed you. But I want to show you like 3 things that are kind of unusual. At least to me they were, and I hadn't thought about them until we did the work. But I have a lot of work recently that has to do with, that's with psychologists and has to do with human behavior. And so this is just to say that what's happening is not just about particles in space or something, that the city is in you, inside you, in the way you think, in the way you behave. So let me show you a couple examples. So it's well known, for example, from our first papers, that people in larger cities tend to walk a little faster. So because time is of the essence, and they're busier and so on, so people are a little bit more animated. But this is an example about depression. We've all been thinking about mental health because of COVID and so on. But one of the main determinants of depression, so for a long time, I should say, people have been worrying about cities being bad for mental health. And there's a lot of the early social sciences literature, if you're in that field, you will know, is about cities must make people go mad or have poor mental health. And so we started to look at this with modern data, and we did this during COVID because people were talking about this. And so what you find, so this is about depression specifically, that's important. But one of the protective effects and important effects in depression is human interactions. So people are very isolated tend to become much more depressed statistically. And so in large cities, I just told you, people have typically larger social networks. So that effect actually predicts that people have less depression by a certain amount that looks like a scaling law. And lo and behold, that's exactly what you get. Okay? This doesn't mean, this is an average effect, doesn't mean that there are not depressed people in large cities, but they usually have to be not typical. They have to be much more isolated than the typical person in the city. So this happens, for example, with isolated older people. They kind of lose their network. So this is important. This makes a prediction to look at these people. Or if somebody is very segregated because of that condition and so on, that would also apply. But in general, larger cities are protective against depression. Isn't that interesting? Okay, so this is another one that is very US, but but it had to do with this is also a theme that has ebbed and flowed in the last few years, but it has to do with people being racist. Okay, and so psychologists came up with an interesting way to measure this, which is a word association game. They show you pictures of different people from different races, and they ask you to associate those images with words that have a positive or a negative valence, good, bad, basically. And you find, so then you can see if people are, this is why it's called implicit bias. You don't ask somebody if you like people of a certain race or if you don't like it, but they just observe your associations, okay? And so what we find, so there's been a large sample of this and so on, so we use this data. And so what we find is that, as the title says, that people are less implicitly racist in more populous, so larger cities, but also cities that are more diverse and they're less segregated by neighborhood, okay? So basically what the experience of mixing and looking at other people is at least neutral, so that prejudice goes away. And what we find is that these effects all count, because you could have a larger city that's more segregated, like Chicago, where I live, and that's not a good experience, because then you have an impression that people are very different, maybe, at least some of the time. But when people are more integrated and just have a normal life, and you know there are good and bad people of all races, then that kind of prejudice washes away. So it's kind of interesting, right? Just to say, it's messing with your head and it's changing your behavior, in this case in a positive way. Okay, and this is a paper that just came out last night, so I'm going to tell you a little bit about. And this is kind of something a little bit different. It's about the built environment, but it's using the ideas about the networks of infrastructure. So the networks of infrastructure, basically what you look at any city is that every building needs to have access to the network. So that means it has an address, it has street access, which is the most important thing. And then it's through the street they usually get water and sanitation and trash collection and ambulance coming to help you and so on. And a lot of buildings in developing cities don't have that. They just have a settlement, but they don't have access to the street and municipal services. And these tend to be slums or informal settlements. They're informal settlements literally, because people just settle down without the legal and physical connection. But it turns out that this relationship, which has been very loaded with, I would say with normative ideas that, slums are bad and so on, that you can just approach it from this perspective of the completeness of the physical network. So here's a picture. So we can do this because there's a census of buildings for the first time that came out 2 years ago of every building in Africa. I mean, this is the age we live in, that every little shack, every house can now be mapped through satellite images and some AI and computer graphics and so on. This is not absolutely perfect, but it's very, very good. And it's going to become perfect in the next few years. So if you like the built environment, just think about a built environment where you know everything. You know every building, every car, every tree, everything. And now you cannot just ignore it. You have to design with that in mind, right? So this is a bit of that. But what you see here is basically going from a continental scale all the way to a street block. So these are street blocks in the city of Lusaka, as it turns out. And you see that some of these street blocks, like this one, have a lot of buildings that are not close to the street. So this is what I was talking about. So these are informal settlements. There are local surveys that tell you that. And so here they are, and you can characterize how far the buildings are from the street, meaning how many buildings they need to cross. And you have other blocks, as you might see here almost on a grid, that have street access. So we basically distinguish this. And what you can see, there's a longer story I'm not going to tell you, is that the places where people don't have street access have terrible human development indices, and the places that do have much better ones. So this is just showing a few, but we've done this for 67 metrics and so on. So these are basically people with literacy. This is what you expect, water on premises. This is sanitation, so these two are almost physical. And this is basically wealth. And you can tell that basically there's a strong association in these developing cities where infrastructure is not there between the people that have infrastructure and people that don't, in terms of many measures of development, almost everything. So development is sort of this network process where essentially you're being connected to a network that's both physical and social. And without those connections, you kind of don't have all the things that you expect from development. So it's the development story, but all the way down to each building. Okay? So we can now do this. Of course, this picture needs to be studied better and so on. But the data for development is not for every building. We don't have data like that, even in Singapore. But you see this as you study things. So you see now that development now is a network process where people need to be connected to other people, both to services and to access to water and sanitation and movement and mobility. But then with that given, then if the social and economic network is also open, they can do that, then you have the effect I've been talking about. And that's essentially what a city is. By the way, you don't see this in rural areas. So in rural areas, people are disconnected. And so what you find is a huge gradient where you may not like what African cities look like or Indian cities look like, but they're much better in terms of development and services than the countryside of the same countries. So development usually is also driven inside countries by the urban environments and then more slowly in other environments. Okay, so I'm going to go a little bit faster, but I want to show you another thought experiment. So this is now a little bit of history. I'm going to take now a break in history. I told you I had many things in this talk. But this is kind of a, as the archaeologists say, this is a natural experiment, but it's the mother of all urban experiments, right? So you may know that the people that came to the Americas, 12,000 years ago or something, did not have cities. They had never seen a city. It was before there were cities. But when the Spanish and the Portuguese got to the Americas, there were cities. So they had invented cities without seeing a city in the old world. They hadn't copied them. They had invented them. So there was a parallel development of cities. And so archaeologists understood this, and they asked the question, well, were these cities the same? Were they the same? Were they the same essential structures? And I'm going to show you quickly that they are. This is just a famous quote from some of the Spanish conquistadors as they arrived. Tenochtitlan was the capital of the Incas. Sorry, I went back and forth. I see you taking photos. You see this almost looks like the shape of Singapore. I thought it was curious. But it had temples in the middle. It's a little smaller, right? But it was a very large city in 1520. And this is what the Spanish saw. So, there were a lot of lakes and water. But basically, they're just saying, oh, this looks even better than the cities we have back in Europe, right? So it's an extraordinary thing. Why? It's what I tried to show you. These people basically came up with cities the same way, right? So anyway, we did a bunch of these studies, they're archaeological data, sort of blew our minds, it was very interesting. I'm just going to show you a couple things. So one interesting thing is that we cannot measure economic production, right? Because all we have is archaeology, so we have space and so on. But we know how much monuments these people built. And so it looks like they put all their social effort basically in building those pyramids and other things. And this is essentially the thing that goes supralinear. So it's a lot of the social effort is tracked by the volume of monuments. And these have statistics that are predictable other places. And then we looked, for example, another postdoc, Jack Hansen, did this amazing study of the Roman world. These are basically the cities of the Roman world about first century BC. You see the big one is Rome. So much bigger than anything else. But they basically could predict, there's been this controversy about what was the size of Rome, what was the population. And so from the scaling law, you basically can predict what it is, and there's a census of that. So it's basically just shows you that in some sense, being a city, this is kind of something we did at the time, there were cities that were old cities, but in some sense, this is latent, right? So what I'm trying to say, there was coming. There was going to be a New York or a Singapore. Okay, the other thing I want to show you about that I think is very interesting is this idea of information, how information shows up in cities. So when you look at a city, it's full of information, all the symbols, everything. But information is very important because it allows you to organize very complicated things. So information in some sense is memory, allows you to look back and remember, but also allows you to look forward and imagine. So I want to show you a little bit of that. So with the first cities, you start getting things that we never saw before in history. And the most important is arguably this one, which is writing. Now, when I teach my students, many of my students are qualitative. They come from the social sciences and so on. So I'll show you in a moment. I see you squinting, but I'll show you in a moment what this is. But this is the first, tablets. Some of you will know what this is, cuneiform writing. And this is kind of temporal, so it's the evolution of that. But with the first writing, what was the first thing that people did? It was not about writing narrative. The first thing that people did, you see what these things are? These are beads. They're counting. They're doing math. So the birth of writing and the birth of mathematics was the same, right? So mathematics and writing were basically obviously informational systems to keep track of things. I'm just going to show you a few. So these things are being deciphered slowly, but these are counting things and so on. And these are economic transactions and contracts and so on. And with writing, you get this, which is sort of, you probably can't see it, maybe there. This is basically an Excel spreadsheet for an accounting, right? So there are lots of these, they found lots and lots of things. But you also start getting this, you get the first voices in history. The first people writing poetry or complaining about their boss. A lot of complaining about their boss from the script, so you start getting things like this, including, basically poems and a little bit, racy poems and so on. I didn't put that part. But so one argument is that when you create information in this way in human societies, this information is the only thing that lasts. So these cities more or less don't exist anymore, but this still exists. Do you know what I'm showing you? So I'm showing you what's known as the sexagesimal system. It's basically the things that we count in 60s, right? So you may think, we don't count in 60s anymore. The people of the first cities, the Ur and Uruk, did. There was base 60, and here's the symbols and so on. I don't know if you've been to the Middle East, but in many parts of the Middle East, people still count like this. So that's what the hand means. They go like 1, 2, 3, 4, 5, 6. So they count to 12, and then they can go 5 times on the fingers of the other, and they can count to 60. So it's a very natural number. It's divisible and so on. But it's still with us, right? Our computers have a clock, and that runs on time in 60 minutes and 60 seconds and so on. When we measure angles and latitude and longitude with GPS, we still do the same thing. This was invented by these people, and ever since it's been used by everybody. So this is kind of amazing, right? The kind of information gets embedded in civilization, and everyone uses it into the future. So this is a sign of many things that are invented by cities. And it's very powerful because it's showing you the cumulative character of knowledge and civilization, which is kind of how invention piles up on things that have been invented before. I'm conscious of time, but I wanted to, this is something that was funny. Do you know the history of the hot dog bun? It's just an example of the kind of innovations that happen in cities, not just about profound things. But this is, I'm not going to tell you a full story, but Germans coming to America, to Chicago and St. Louis and New York, they have little buns. If you ever go to Germany and try to have a Wurst, right, a hot dog, basically, the bun's too small. And so you see here that to Americans, they had to give them gloves, and then they didn't return the gloves. It's a whole mess. So they basically had to invent a way to make Americans eat hot dogs. And so they had to invent the hot dog bun. The hot dog bun does not exist in Germany, but it was invented in the US. And there's countless examples of this. It's just lots and lots of things like this. So what I want to ask you, suspend the question, is this. So you can think of things that we still live with, from all the great cities of the past. But I want to know, what will Singapore be known for? Like, Ur is known for the sexagesimal system, or Rome is known, for engineering and the law and language and so on. What will Singapore be known for? Is it chili crab? Maybe. But you probably have to invent the gloves for the Americans to eat chili crab or whatever, But I think, a good chance is urban forms, maybe green buildings or urban planning of some sort. But it's a good question, what is it that Singapore will invent that becomes world culture, that lives forever? That's a sign that you've arrived, right? That you've really gotten there. So think about that. I'm not going to give you an answer. But okay, this is the end of this part. And it's basically that when you have cities, there are many things, some quite abstract, but extremely profound, that become necessary for the cities to function. But that these things affect everything that will come into the future. The most important thing about humans is symbolic culture, that we have symbols and that our knowledge is externalized so that other people can learn it more easily. And so this happens with cities, like with writing, mathematics, all these things, symbology and so on. But there are also things like division of knowledge and labor, social interdependence, trade, public goods, like public spaces, but also monuments and so on. Social contracts, law, resource distribution. These things are not invented because they're nice. They're invented because they're necessary. And they keep evolving, right? And so, but these things once invented, because they invented to large populations with very diverse people are fighting with each other, they're very robust and they're very general, and they can basically influence all the systems that will come because these problems are general, okay? Okay, so I just want to finish with sort of the theme that we've been discussing this week, which is how do urban science, these ideas, which as I described, is quite qualitative, but I hope to convince you that they're sort of a basis of mathematical models and general principles and general ideas, may allow us to conceive futures of the world, of the future. And a lot of what you're asking in Singapore are these ideas: livability, sustainable, resilient. But in some sense, these are aspirational. They're not scientific questions, right? None of the cities in some sense are sustainable, resilient, and so on. And these are also unsolved problems and unsolvable in detail, right? A city will never be absolutely livable. There's always probably ways of improving it, right? So it's just things that can improve and get better. So this is kind of a theme that I don't want to elaborate too much. I'm conscious of time. But if you've listened to my talk yesterday, I mentioned some of these things. But the way cities, so I think now you understood that what's important about cities is that you have many people interacting, trying to solve various problems. So it's a distributed system with a lot of bottom-up and top-down dynamics. And it's in that diversity and variety and experimentation that you solve things. But also a lot of things take time to accumulate and to change. So the way cities have always solved problems, if you look, for example, at your water system that we've been talking about all week, whatever is your greatest glory, right? It took decades, right? It took decades to be what it is today. And that's the nature of any urban solution. However, cities are able to create extraordinary things, but it does take time and does take complexity. Again, think about tangible things like your water system or your governance and so on. Okay, so I want to talk a little bit about decarbonization and just show you the state of things and give you some examples. So this is more or less the state of decarbonization today, actually, so that we're not too pessimistic. Things are getting a little bit better. This is basically carbon emissions per capita. So if population are increasing, may still be increasing, but per capita, they actually tend to be going down in developed nations. In Singapore, I didn't show you the graph because it was too busy, but Singapore is actually quite energy intensive compared even to a city like New York. But you see here that carbon emissions in Europe were about in the 90s peaked. In the United States, they peaked in about 2003. So it's been going down even in the United States. So this is good. But how are we doing this? And can we go faster? Okay. So you know that national policy is not working very well, right? In large countries like the US, but even Germany now and so on, it's kind of wobbly and sensitive to politics. But cities have been doing a lot. And of course, it's much harder to decarbonize Singapore or New York than it is, to do that maybe in a smaller town. But this is sort of how New York has been doing it. So what is interesting about this is they've been doing it for almost 20 years, starting in 2006, 2007. And the plan was actually very timid. It was about 30% reductions. That's what people were talking about back then, relative to by 2030, right? And what you see is this is the timeline of what happened. I'm not going to elaborate, but that this plan, as they learned how to do it, got more ambitious and got more complicated, but also brought up the goal to total decarbonization. Okay, and this is typical of many cities as they actually go through the process. If they don't go through the process, they can't do this. And they don't solve this essentially by having a specialized department of decarbonization. What cities are figuring out is that they need to get to what you call here the whole of government. Everyone has to do a little bit, and you have to figure out what different sectors can do, and they have to work together. So this requires lots, it requires, lots of 132 initiatives, 400 specific, milestones. This is a complicated thing. It requires everyone to be working together a bit like a city, but it's working, and this requires many innovations. So one of the things is that this led to an alignment of these processes with the UN process of voluntary local reviews. Singapore also started doing this, but this allows you to start comparing what you're doing to other cities around the world and learn from each other. This is sort of the alignment of that with the Sustainable Development Goals. It's a crazy thing. It looks super complicated. But the point is that in some sense, these alignments are complicated because there's been improvement in many parts, and sometimes some parts of the system go faster. For example, New York discovered early on that it could decarbonize its power supply. So then it stopped coal-fired power plants that reduced things. That was low-hanging fruit. But then it discovered most of its problems were buildings. And then it had to start analyzing buildings and so on. I'm going to show you that. They had to do a whole inventory of buildings, see what kind of building was consuming more or less, and start creating incentives to do that. In the beginning, no one knew how to build, to measure the carbon emissions of cities. So they had to invent a protocol that allowed comparability. This was done in the context of C40. in order to do that. That's amazing. You know, this is not that long ago. And when you do this, you find, when you measure, you find surprises. Okay, so I told you about it yesterday, but this is kind of interesting. Melbourne, everyone knows, is a bit like an American city, so it consumes a lot. But Rotterdam was a surprise, which is a Dutch city, right? So if you've been to Dutch cities, they look very nice. You know, how come it was the worst city of all, right? And the reason was similar to Singapore, the port. They have a big port, the biggest in Europe, and the port is a horrible thing. They also had not decarbonized their energy supply, but then they had to figure this out, and they figured this out because they measured it. And then they started doing stuff about the port, and now it's better, you know? So all I'm saying is that we don't know the problems until we look at them and we start solving them, and that requires a broad lens and then start to do that. There are also lots of things that are happening, like New York City. This also figured out, of course, and many cities are, that a lot of their carbon emissions are actually not local. They have to do with they're embedded in products that you consume, but that maybe were produced in China or elsewhere. And so you have to start accounting. If you're really serious, you have to start accounting for that. So this is very difficult to do, because imagine all the life course of a product. But then they're starting to do this, and this becomes essentially a way to do it in other cities. So this is still going, but it's very interesting. And then you can see who consumes more or less. You see the rich people in New York consume more, as you'd expect, and you know, and so on. But this is going to be becoming possible because you ask the question, you try to go that. And this is what's happening also. This is Los Angeles, had a similar story of getting more ambitious as it goes. It happens in Copenhagen, supposed to be carbon neutral this year, maybe. That's the goal. That's what they said. And London, in a few years from now, we'll see if it happens. But you know, London has a long history with air pollution and so on. Okay, so this is basically my last slide. I took you on a crazy journey, right? Through history, through different countries. I made you think, put you hopefully in different positions to make you think about this and that. But I want you to appreciate that even though cities are familiar to us, they're also extraordinary things that are revealing in many ways the fundamental nature of humans and the fundamental potential of humans in terms of creating new things, solving new problems, creating some as well as we go. But then, you know, in some sense, harnessing the potential of our social creativity to create, in many ways, completely different futures, futures that no one can imagine individually, but that together can be achieved. So we're just starting to understand this. We see it happen. We know a lot of how it works. But, you know, cities are not just bunches of problems. They're really sort of the magnifiers of human potential. And hopefully that's what you'll remember from this talk. Thank you. Do I stay? No.
Yeah.
Okay. Ah, okay.
Thank you very much for that inspiring lecture. I'm Sharissa from the URA's Design and Planning Lab. I would now like to introduce our moderator for the evening, Prof. Alvin Chua. Alvin is the research director at NUS Cities. He holds a PhD in engineering from KU Leuven in Belgium. His scientific and technical interests are in the applications of artificial intelligence, geospatial modeling, and simulation in urban planning. Prior to his appointment at NUS, Alvin led the data science and engineering practice at the URA Design and Planning Lab, where he was responsible for the building up of urban science capabilities through research partnerships and in-house technology development projects. With his breadth of experience across both academia and practice, Alvin is well placed to moderate tonight's session and steer the discussion with insight. Please join me in welcoming him on stage. We now invite the audience in the auditorium, as well as those of us joining us on Zoom, to raise their questions. Alvin, please.
Thanks, Sharissa. Thank you, Luis. There's this iPad that I'm supposed to look at, right? So later on. Anyway, Luis, that was an amazing talk. You are most well known for your pioneering work on urban scaling laws. The discovery that many social, economic, and infrastructural properties of cities change in systematic, predictable ways, right? That's your key finding. You frame cities as networks of human interaction, much like living organisms, with emergent properties that can be studied using physics, complexity science, and network theories. Your work has been published in both Science and Nature, extremely prestigious and well-regarded academic journals. In my opinion, you've made significant contributions to knowledge by laying solid foundations for a unified science of cities that blends theory, evidence, and practice. Amazing. I feel that that introduction should be given. That's the non-lay introduction, and I must say that I really respect Luís as a world-renowned scientist. So I've got some questions for you. I won't talk about the technical aspect, right? But I've seen through the profile of our audience, it's a really diverse group of people. So let me begin with one or two questions, and then we'll take some questions from the audience, right? One of the key things I recognize is this idea of scaling laws, right? So in your paper in Science, you showed that many features of cities, and you mentioned that earlier, right? From innovation to infrastructure follow scaling laws. Can you share what surprised you most, right, about these universal patterns? And what do they tell us about the future of large urban areas, right?
Okay. I think that, there's several things. First, you hope, but you don't know until you do it, that, these various effects I show you pictures for could kind of be packaged together into a relatively simple model that has this spatial effect and this temporal effect. I think it was very interesting to see that you could see also the limits of this. So you could see, for example, when it breaks down. So if the benefits of social interaction is not sufficiently good, the predictions that cities should break down, and likewise, if the cost of moving around in order to interact becomes too high, then also cities should break down. So there's sort of a bunch of predictions like this. A surprise was, I showed you all this data on historical cities, was that as I was finishing that work, a friend, Scott Ortman, who's really the main author in lots of these historical papers, asked me to explain to him what I was saying, what I was writing in this paper. And I said, social networks, infrastructural networks in the sense. And he just looked at me and said, but that's not modern cities. That could be any city. And said, you're right. Okay, I'm going to try it on my cities, which were the Aztec cities I showed you. And lo and behold, it works. So the point is that the mechanism, even though I was trying to explain, the cities we had data for, which are mostly American cities and a few others, it was a very general effect that would, at least in principle, apply to many more general contexts. And turns out, certainly with all these tests in historical cities, which feel different, but in some sense have these essential dynamics of social and infrastructural networks. And then in cities in many other parts of the world, including many developing cities, it also works quite well. But you also see some of these issues, like when the network is less complete and so on. So it allows you to think about many more things than what I had put in, so to speak. And that's always good.
Thank you, Luís. Let's see. I'm not sure if I want to, okay, I'll do this, right? That's a question that came in virtually, right? And it's from Sarah Lynn. I don't know if it's the Sarah Lynn that I know. Perhaps it is. If it is, hi, Sarah. I'm looking at your question now. Sarah says, thank you for the talk. It was very informative. I have a question in reference to the building of culture with your expertise. What would be your advice and recommended readings towards the building of culture, inverted commas? Thank you.
Right. So, there's a whole other theme that I didn't elaborate too much, even though I gave you this historical perspective and a little bit the history. Culture is created by people in interaction, right? So the most important part of culture is language. Here we are, right? And so allows us to communicate and coordinate behavior and so on. But the point is, in some sense, I think you could look, I don't know if this is the spirit of the question, but so culture is necessary for a large number of people to interact and productively. But cities, in some sense, put you in this complicated place where you're bringing people from different cultures together, typically. If the city's big enough, that's almost inevitable, and that's even true of old cities. And so this is kind of uncomfortable, right? This in Singapore, it's a very intercultural, but it's also very generative. Like, I think, actually, if I may, the history of chili crab, right, is a bit like that, right? You had people who were, I could get this totally wrong, so I may get in trouble, but and I know people are passionate about the chili crab, but I think the family was Chinese, they're boiling their crabs, and then they were bored with this, and then there was ketchup, and there was spicy, which may be slightly from a different culture. And that was amazing, right? It's a bit like the hot dog bun, right? And the hot dog. So these combinations become not only likely because the ingredients and the people are around, but almost necessary, so that that idea, that thing, can become available to more people, either for business reasons or for other reasons. And so in that sense, cities are kind of cultural machines. They're places of invention of culture, of clashes of culture, but also typically of invention of culture. And there are these very interesting phenomena that, if you ask most people in Singapore, you can't quite do this because everyone lives here. But if you ask Americans what they feel about New York, they'll say, oh, that's an alien place. If you ask Japanese what they think about Tokyo, they go like, Tokyo is weird. It's no longer just Japanese culture as they imagine that is, but it's kind of something new, right? That's kind of getting ahead of itself. And so cities are interesting because they set culture in motion. And you see a lot of these effects if you love to study. I love to study this, but this is hard to study, in language evolution. So for example, an interesting thing to see in cities, and not great data on this, but there are some census of languages in New York and London and so on. Maybe you could have that here. But at some point there was a census, there are about 800 languages spoken in New York City. And 800 languages, you go like, how many languages are there in the world? And some of these languages are extinct back home, but they still are spoken by certain communities, and they're alive as well as they're mixing. So there's sort of the ability to both keep culture, because people can be diverse in cities, they can become weird, but at the same time they can bring things together and create new ones. So in some sense, you see culture in motion and being invented in cities, and I think that's super, super interesting.
Thank you, Luís. Is there any, can I take a question from the audience? Right, the microphone's coming.
Thank you, Professor Bettencourt. First of all, thank you so much for a hopeful, optimistic, and very insightful lecture. It reminded me of another UChicagoan Professor Carl Sagan's lecture, which was very hopeful.
Oh my gosh, okay.
So thank you. I just was curious if there is a law, there are laws for cities. Do you think we're at a tipping point? Back in 2007-8, there was this sense that we're all moving into cities, everything's going to be urban. But there was perhaps, in my opinion, an overestimation of sort of the economics of cities. So economic geography, we started to interpret things, and that's great. Now we have some kind of a layer of understanding that. Do you feel have already crossed or are at a tipping point where we hopefully understand these laws and start to produce maybe eusociality and you mentioned good in brackets. So how are we going to create good cities? Is it through a science of cities?
I mean, it's a bit like, I would answer this way. I mean, it's not, we don't know, right? It depends how you use it. But I think as always, the ability to understand something opens up new ways of thinking and acting. And I think for a long time, even urban planning was about all the pesky problems of cities that you need to bring down and solve. But I think in putting this, thank you, this positive spin, this positive understanding of cities as all the potential of humanity and so on, it's very different because that becomes the thing you want to encourage, right? And that's so I think that is different. And the problems are just management problems, right? But they're not the main dish anymore, right? It's just like, what could happen? What good could happen? So I think that that's very important. And I think what I tried to do in the last part of the talk, obviously it's just still, we haven't solved sustainability, but it's to allow us to start understanding how cities and people in cities are solving really complicated problems, including inventions that nobody asked for. They're super interesting, but also complicated problems. It's very hard to solve any of these problems without integrating a lot of knowledge, a lot of people, a lot of organizations. And so if we understand that, I think if we encourage it, I think we have a better chance of solving a lot of the issues ahead of us more quickly.
Thank you.
So we need to encourage that dynamics, and maybe as we understand it better, we'll be able not only to encourage, but maybe even replicate it in more intentional ways, maybe in smaller cities and so on.
Thank you. A quick follow-up question. And in your work and in your research, do you observe nature and you look at biological phenomena like how ants and bees and other eusocial animals live? Just curious about that.
Yeah, that question for people in complex systems, we like to compare different complex systems. And, cities, as you know, everyone has thrown every metaphor at cities, from, organisms like bodies like us to, of course, eusocial insects. I'll come back to them and say a little bit about each. To ecosystems, to brains, the smart city metaphor was that a city was a brain and so on. And, I mentioned stars, you could try that, but each one of these systems has a little bit to say, but it's not quite right. So, organisms, for example, are actually quite weird if you think about it, because they have death built in, right? They age and they at some point cannot go on and reinvent themselves, whereas cities can. In that sense, they're a bit more like an ecosystem. And so this is a very important character of cities. And in Singapore, you should be aware of this, is that cities are, in some sense, very creative and very capable because they're open systems. Because new people come and other people go. And buildings get repurposed, places get repurposed, organizations have new problems. That openness of the dynamics is very important. You don't get that in an organism. And sometimes you don't get it in other complex systems. And because of that, the informational part of the organism is very different. Even though it looks spatially sometimes, there may be the networks, the blood networks and so on. But another thing that's weird, if you think about the organism is super controlled. If you thought of an organism like a society, it would have to be a super Nazi society, super organized. If you step out of line, I'll kill you, right? That's what you do to cells. And then, if you think about how a cell talks to another cell, it's through blood flow and other things. It has to go all the way to the central point through the heart to get to another place. So if you had to go through Times Square to get from one place A to place B in New York. So cities are much more distributed systems, much more open systems, even though they have some similarities. Ecosystems are a bit more like that, but if you look at the diversity of cities, again, there's no one-to-one comparison. They're also ecosystems, interestingly enough. But if you look at diversity of professions or functions, cities are much more diverse per unit of space or population. And that's because, and many reasons, but they bring a lot more resources in. So cities are fed by resources coming in. Much more ecosystems depend on basically local resources, sunshine and water and so on. There's some exceptions like rivers where there's a flow and so on. But cities can do all that they do because they're very high powered with a lot of energy and resources coming in. And this becomes a problem of sustainability, but also allows them to go very fast, be very energy dense and so on. So they are different in some ways, but the comparison is useful because they allow you to understand each system in comparison to others. The eusocial insects are very interesting. Some people, I'm not at all specialist, but again, the agents, the creatures, are much simpler than humans. And so humans have a lot more behavioral flexibility in a way that ants don't. Ants have a little bit, but not enough. And so in some sense, the potential for adaptation, complexity of organizations is much higher for us. And so that's essentially why we have more of this open-endedness of our organizations than insects, even though, of course, we cost a lot more energy. All right. But there are similarities there too.
Yeah. That was a pretty good question.
Yeah.
Triggered a lot of points. I see that we have some questions here online too. But I'm going to take the opportunity because, I feel like many of these points we're talking about, it's more or less a continuation of the in-depth discussion we had with my team over at NUS. Let's put it this way, right? I come from an application perspective, and for the longest time, I had trouble trying to figure out, how is it that I should be understanding scaling laws and what are the applications of it. But hearing Luís speak about this today, I begin to find a different perspective on this, right? It sort of framed my mind. It is rather a framework for me now. It's rather a framework of understanding things, right? But I have to ask this question in order to stage one that comes online, right? So do you think scaling laws could eventually become part of a toolkit, right, for city planners I've always thought about it this way, right? Could it be something that we use for, diagnostic or for forecasting? Now I think very differently about it. But this question remains, should we be thinking about how else can we be thinking about it, right? I now figure we probably should be thinking about it as a conceptual framework. But yeah, you give your perspectives on this because you may or may not agree with either framing, right?
It's a tool, so a tool can be used in different ways. We didn't spend a lot of time. I didn't spend a lot of time explaining, but in scaling laws, you essentially have a population of cities, a number of cities, and they vary by population size, say, and you're trying to compare them on an attribute like their GDP or something, right? And when the cities are related, so they're typically in the same country, like US cities or Chinese cities, they tend to have the relationships I showed you. But if they're in different countries, because, for example, if you compare Chinese cities to American cities, still true, even though things are changing, the American cities have much higher GDP. So they would look like two scaling laws, not the same one, okay? Even though, Shanghai and Beijing might be richer than small American cities at this point. But, it's not the same scaling law because the baseline is different. So there are differences like this. But you can use them, for example, you could ask the following question, which I think is an interesting question to think about. We're in probably, for those of you who are a little bit younger here, let's see, we're in 2025. You have to be quite young, but if you're in your around 20 or earlier, you may live to, my son is 15, so I tell him this many times, you may live to see the end of the century. What will the world be like in 2100, right? And it's expected that we'll get cities that are very large, particularly in Africa and India, depending exactly how they'll develop. But we may get cities, so for example, Lagos, Nigeria is supposed to be a city that may go to 80 million people, so twice the size of Tokyo. What will be like? So you could use a scaling law by saying, if I went, I don't know, look at Tokyo, look at New York, and now, scale it by 2, and we know that all these things will go non-linearly. So it will be quite dense. It will be very fast in terms of interactions. We'll have all those interaction rates. We'll all be, we're already doing this if you haven't noticed, but we're already starting looking at the pop culture that's coming out of Africa and West Africa and the music and the ways of eating and all the mannerisms. We're doing this a little bit with Asian cities at this point. Now Korea just came up, right? But for a while, we're doing this in Japan. So these cities become culture production machines, both locally, very fast ones, crazy, they'll be like very fast life, but much faster than anything we've experienced. If you go, I know Tokyo doesn't feel quite what it used to be, but you can still go to parts of Tokyo and just, it's exhilarating, like all the people crossing, all the things going on, all the lights, all the symbols. And so basically Lagos is going to be a crazy experiment, right? But you can predict the numbers for Lagos using a scaling law, and you can prepare for it. And we're doing that with this work I was showing you. So you can prepare, how much infrastructure you're going to need, what kind of density you're going to have, how tall the buildings should be, how fast people will behave, what would, I didn't show you that, but we have papers because these networks are denser. If you have an infectious disease, how fast will it go? It's much faster, so it's much more dangerous. So all these things are predictable through scaling laws. But then the most important thing, again, is the concept, because I showed you also these examples of depression or what people have prejudices against each other and so on. So this is not about the scaling law per se. It's about the mechanism underneath. It's the mechanism that if you are in a social network with more or fewer interactions, you will have a different experience and you will be different yourself. So if you're in a larger social, so for example, this is very interesting. It's observed now, because we're getting better and better data, that when you look at richer people, like say in the United States, but probably it's true here too, that they tend to have larger social networks. If you think about people who are richer and more educated, they'd have social networks that are much more about professional life and various interests. These are not good friends, but they know a lot of people. It's easier for them to find a job, to move around the world, and so on. Whereas poorer people tend to have networks that are much more local, to do with survival and basic things. So you can start thinking about development as even the process by which this changes. When people have needs satisfied, they can dedicate more time to knowledge and economic activity, and their networks will change, okay? So this is a little bit what's happening, and this is what scaling, the theory of scaling is about this, about how social networks change under certain spatial, but also service developments, and then, provisions. And then as this happens, then you expect social networks will change, and then people become different. They become a little more callous, calculating, but they know a lot of people, they know more stuff, they know who to call, all these things become different. And so that's the prediction, and that's not about the scaling law, it's about the mechanism. Okay, so that's just some examples to make you think. But anyway, so those ideas, so it's much more important to know the mechanism than to just apply the rule of thumb that comes out of the scaling law.
Okay, Prof. Marie, I see that you have your hand raised,
Yeah.
but before that, I want to get to my colleague Naveen's question, which is online. But Luís, what I took away this morning, it sort of changed the paradigm for me, right? It's about understanding that there are characteristics, properties that change over scale, and it's useful to have knowledge of this, and that leads me to Naveen's question, right? I'm gonna read it. Hi, Alvin. My question would be on how scaling laws run into the problem of inequality in cities. Specifically, if how we do a lot of statistical work in terms of averages, means, and medians might be getting overly rosy picture of progress in cities, where numbers look good, but the benefits might only be accruing to a subset of folks.
Yeah, so this has been studied a lot. It's a more complicated story. It's a bit more complicated, but it's very important. There are some papers by some colleagues at SFI, Chris Kempis, and others that show that, at least in American cities, it looks like a lot of the advantages of scale are being accrued to richer people. But we also have a study coming out now with the Indian data, which is not great data, but that shows that in India at this moment, that actually the poorest parts of the population are benefiting a lot from urbanization. They're catching up somewhat. This may explain a little bit why urbanization in India is actually being quite positive, and India is going so fast. So this is to say, yes, inequality is very important, and I should also say, I showed you some distributions, but very fast. We also know the statistics under the scaling law, okay? So this is just requires, it's much more technical argument. But the statistics, for example, wealth or income or number of connections in a social network or many other things is log normal. The reason for that is a little technical, but it has to do with the fact that the process is multiplicative, that you get more money, the more money you have typically, and so on. It's kind of, or knowledge is like that, because I showed you, like, if you have a certain amount of knowledge, you can acquire more knowledge. So they tend to be these effects like this, and because of that, these distributions, a log normal distribution, if you know what it is very broad. And so it means that it has a lot of inequality, okay? So inequality, so that's just structurally what you get in statistics. Now, of course, some societies are more inequality than others, and inequality in different societies has different meaning. So what I was trying to say is that it's important that people can interact with each other and learn and maybe change their situation. So you have to ask the question if inequality is preventing that from happening or not. And that's more of a contextual question. So for example, inequality is also tricky the following way. When we measure inequality for a city or a nation, you may think, well, it has a certain amount of inequality, Gini coefficient's 0.47, which is, I think, what it is for the US. But who are you comparing? So for example, is it fair that a young person, many of you are young here, and an older person, do you expect them to have the same income? The professor and the student? No. Should you put them in the same distribution? Is that unfair? The professors will say it's not unfair. But but you expect, right, as people go through their careers and so on, that would happen. So for example, what about if it's men and women? Of course, you expect them to have the same income, right? If they have the same age and the same characteristics. So there are ways in which this inequality may be unfair or may be explained by certain factors that are okay, and they're part of, life course and experience and so on. And so this becomes important to kind of unpack that and see if inequality is revealing unfairness and obstacles to, people realizing their potential, or if it is structural for other reasons. Okay, now when we see, inequality grow and so on, it usually means that's bad, right? But sometimes, this tends to come with larger cities because very rich people live in cities too. So you end up with the billionaires and so on that push the distribution. It's much more important, for example, to know if the poor people in Singapore or New York or whatever, how do they live? Do they live worse because there are richer people, or do they live better? Because in a city, maybe, in a city also what you get, this is not to make it rosy, but in a city you need to have services, right? So you need to usually have public schools, and you have a bunch of things that now are provided by the city and the society. So the inequality is not just to do with, wealth in terms of money, but it's also about access to things in life, right? So again, a lot of the way societies mitigate inequality that's economic is by providing sort of ways of people to living well and having access to the system that's not always economic. But for example, in the United States, we have a lot less of that than compared to Europe or Asia. So when you look at economic inequality in the United States, those people cannot afford a good school, probably, depending where they are, or certain services. Whereas if you look at it in a place that has very good social services, maybe it's different. So I'm just saying, I think we have a sense that inequality is unfair, it probably is, but you have to then understand what the obstacles that it is creating are about. And that's a little trickier.
Thank you, Luis. Can we have a microphone for Prof. Hada?
Hi there, Mary Harder, Fudan University, but affiliated, I guess, somehow with NUS Cities. I'm very interested in the fact that we both come from kind of hardcore sciences, physical sciences, and I've somehow ended up in this kind of quasi-anthropological, sociological, cultural area of cities. And I'm quite curious the extent to which you think we're still in science at all. I went to a really major cultural studies professor's talk in England, and he expounded on an idea he had. And after about 20 minutes, he exclaimed how convenient it was, how wonderful it was that he had finally, after 5 years, found an example of what he was talking about. So he really went from the other way. He went from describing a cultural interpretation to being able to find one example of it, which is really the other way around to how what we normally call science works, where you first look for patterns, then try to find the important variables with them, and then hopefully can use them for describing. And then if they're very good, you can use them to build up explanations. And I'd like you to comment on the extent to which you think what you're doing now is actually any science. Shall we perhaps say, to do really good cities work, we need to maybe wipe the slate clean and say science isn't maybe a good place to start. Maybe cultural studies plus other things mixed together is more important than trying to do what psychology was, where they have lots of correlations and they call them explanations. They're not explanations at all, they're just correlations, right. But they say this accounts for this, and it doesn't account for it at all. So a lot of the things you've done tonight have gone from both directions, and I found it fascinating because I think cities needs that. I think we need a new way of looking at things, but traditional academics don't. They tend to put science on a pedestal as if it's a god or something, and ignore the fact that actually it starts by looking for patterns and say, no, let's forget that. Let's go for experimental bits and statistics. So what do you think? Do we need a whole new way of looking at knowledge and forgetting about science and calling it something else?
Thank you. I think people fight about what science is, so I understand the misunderstanding. Like they would say physics is a science, but some social science perhaps less of a science. I don't think that that's right. I think that you can be in physics and do it like it's not a science, and you can be in that social science and do it like it's a science or not a science. So it's more this attitude. I think that and again, different disciplines do have more people doing one or the other. I agree with that, and that's just an historical thing. But my point, even though it was not my main point, is that we can have a science of cities in the sense of, you echoed a little bit what I said, that we have general facts, they're sort of empirical facts that we can measure and verify or falsify, and we have explanations. that predict those facts and predict a bunch of other things too that we can go measure. Well, I showed you some. You may agree or not agree, but it's just the claims are out there, and I make those claims, and other people make those claims, and that's the exercise of doing science. Is that some people agree, some people disagree. They have to go measure by themselves and see what they get. But to the extent that we see patterns recur and we can predict things, we're doing science. And that's what science is. But science, above all, is an explanatory framework that always is getting better. So some of the things we understand in general terms, some things we understand better as we go, right? And so it's open-ended in that sense. And we don't understand everything perfectly, obviously not, certainly not in cities. But we understand some basics now in a way that we hadn't dared to do. And I think we have to dare and see what we get and work from there and keep poking at it. But I would claim that we understand enough that's general, that's predictive, that's been tested through history, tested in cities all over the world, that's predictive of new phenomena. It's a science. Now, I don't think you can just call a discipline and say physics is a science, mathematics is not a science, anthropology is not a science, sociology is a science, economics not a science. I would say that. And so on, but it's just, but it doesn't matter what I said, which ones were or which ones are not. I mean, I left physics, I'm a physicist by training, because at the time I'm a theoretical physicist, and theory is not always science, and we had a lot of string theorists. I don't know if you know what string theory is, but it's supposed to be a theory of gravity and quantum mechanics and so on. And it has no experiments. It was just people building models, hoping that would explain, the beginning of the universe and so on, but it could never be tested. And I think that was not science, because you could not know. Whereas in cities, you sure can know. We just have avalanches of data, and if you know how to look, you could test if the idea is right or wrong, at least if it stands. And so that's the exercise. So yes, we have a science of cities, an urban science, and it will keep getting better. And no one should ever say, this has been proved wrong so many times, that you could not have a science of X, right? People thought you could not have a science of the cosmos. You could not have a science of biology. You could not have a science of biodiversity. You could not, geez, of course. I mean, all these, of course, have been proven that we can have a science. It's never perfect. We don't have a quantum gravity, but we have pretty good physical science that takes people to the moon. We cure diseases, we understand many aspects of evolution that we can now replicate in the lab. So, absolutely. It's a science.
Thank you, Luís. We can get back to that, but I think we have a question from the back, right?
Yeah. Hi, Professor. Thank you for the inspiring lecture. I think in the lecture you mentioned about innovations in future cities, which actually reminds me of narratives about blockchain technology in urban governance. And I think blockchain scholars often say it can break barriers across systems like healthcare, supply chain, solve issues like system silos, and lead to ideal future of citizen co-created governance. But is it really realistic? And why should we actually give up centralized systems that already provides us with good sides of economies of scale? And how should we actually approach such a problem? Since, as you mentioned, cities are just so complex.
I mean, thank you for the question. I mean, okay. The first thing I want to say is that the role of science, if I may, is to show that things that we think are apparently very complex and out of reach are not. We can actually understand at least many aspects of them and keep understanding them better, right? Who could think we could predict the beginning of the universe or the end of the universe? I mean, that's crazy. And we're still not sure, but we can see many things, out of a theory of space and time and so on. Or biological evolution. It sounds like, that was a God thing. And yet it works amazingly well. I mean, you can do all these things now in the lab. So the point about science is to try to give us points of view and explanations that are simpler and that are generative, that allow us to predict new things. And I think we're getting a little bit there with cities, though, of course, scientists in the field should always be fighting over that. How much can we do? Is this a good test or not? So just to say that. With blockchain, with any new technology, we go through the cycle of thinking, my God, this is going to be magic and solve all the problems. we've done this with smart cities, we've done this with AI now, we're going through that, but there are many, many examples before. And it usually never pans out that way. We need to figure out how to use that technology in ways that are appropriate and solve interesting things, and that hangs around like the sexagesimal system, and people keep using it in different ways. If we all die, if humans die, the computers are still stuck with the sexagesimal system, right? It's amazing, right? Crazy. Unless one day that, so the people of Ur didn't know they were doing that. But I would say that a lot of what we do in cities with, blockchain is several things, but it's a ledger. So it's a way of keeping track of transactions and events and attributions. And that is part of social life. In those clay tablets, it's a different technology, but people are keeping track of contracts and transactions and things they will own and futures of certain things. And so we need that kind of technology. The question of whether blockchain is going to be better than other things, and moreover, such accounting systems are distributed. They don't belong all to the same place, even though they need to be recognized by different people as a valid register. And so, blockchain has a lot of these properties. So maybe it has advantages over some of the things we have, and I think that's why people are exciting. But I'm not sure that it provides, and the question is it so much better that everyone will adopt it? Maybe, but it's not clear yet. But, it could happen. It gives us a distributed way of doing many things that we need to do. So from that perspective, it's interesting to push on it and to see, if it becomes better, superior to other ways of doing that. It's being adopted somehow, but it's not clear that it's maybe too clunky, too abstract to a lot of people to use.
Do we have a question from behind? No.
Hi, okay. Thank you so much, Prof, for the eye-opening lecture. So I have two questions for you. So the first one is, both questions regard the implementation of your research, let's say. So for the first one, as more and more data and research is contributed to the literature on city science, and let's say the city planners have access to this knowledge, are you optimistic that developing cities today can grow even more sustainably than already developed cities? And so my second question is, on the flip side, right, many developing cities today have already adopted very unsustainable practices. So let's say traffic congestion is quite bad, right? And many of these practices are already entrenched, and there's no easy way to get out of this. So how do these cities dig themselves out of the graves that they have dug? And how can your research contribute to this? Thank you.
Yeah, to the first question, a lot of, let's call them developing cities, as you did. A lot of cities are developing, and they're particularly in South Asia and West Asia and Africa, they're still growing. And so, they're building their infrastructure, so that's happening. Whether it can be sustainable, in some sense, if you go through every day, day by day, what they're doing is not sustainable, as you said, because they're trying to use the technologies and the ways in which we built other cities, including Singapore. Singapore is not sustainable, even though it looks green. It's actually very energy heavy and resource heavy for reasons that have to do with your own security and so on, but those were built in. And I saw a lot of traffic today. It's got a lot of traffic here. Maybe it's worse in other places. Here is more organized, but still a lot of traffic. So, the point about my lecture and some of the things I said is that traffic is to be expected. People need to move around, but they can do that in different ways, right? So, but I think developing cities in some sense, because of the main problem, right, at the moment is climate change and carbon emissions. That's one problem. And the other problem with environmental sustainability is mostly to do with biodiversity and destruction of ecosystems. And that is mostly to do with land use. Most of the destruction has to do with appropriation of land use for farming and food. And so to the extent that we could address those issues, then cities could develop with less of a footprint. You see some cities leapfrogging. In India, you see very fast adoption of small vehicles like bikes and tricycles and so on that are becoming electric. but they still need to move around. So it depends on whether that substitution can happen fast enough and if power producing. So they're doing better already than cities of the past, including Singapore. But it's just that they also need to develop. So the big tension is between the need and the right to develop, now that the path is open in some sense, but also then the sustainability locally, but also the rest of the world. So everyone needs to help those technologies happen quicker. And of course, we're kind of at the moment in a difficult international environment. I think what you said, they're developing wrong and so on, it's in the nature of cities that they do a lot of things in a distributed way. You know, you have traffic because everyone wants to get to where they're going. So there's no system. I mean, there's a bit of a system, but it's not commanding what people should do and so on. It's unnatural that that would happen in cities. So you can only have incentives, technology change, and so on that allows the things that need to happen and the decisions that everyone is doing to be more sustainable and yet to lead to the interactions and development that's necessary. But I think that we have this knowledge that we understand both what's necessary and how we could, and what can be substituted, and it's not essential. It now allows us to start thinking about that in a much more clear way. There are many people that still think that you cannot have development without being unsustainable, right? So, but think, for example, about energy. We actually already know, though we haven't done it, that to use energy that's renewable, that's captured from the sun and the wind and so on, in a way that would at least potentially remove the carbon emissions. That's why you see all those curves coming down. So we know how to do that, and we know how to build things that are more efficient and so on. It's just the economics and the distributed nature of the process, and also the fact that developing economies and cities, you know, people are poorer, so they're using usually old technologies, and they're copying what other places have done instead of leapfrogging. It's very hard for an economy that is, or a city where people are poor and where they don't have a lot of experiences of success, to try something crazy that never been tried before. Who does that? You know, so they're going with what is known and what is available, and that's essentially the problem. But it's the problem that everyone has had in the past, including Singapore. It's just that now it's critical for the world in a way that needs to be helped. But I think the fact that we're conscious, you know, that we know how to substitute certain things in principle, then allows us to have much better solutions. And you see the result. It's just that the improvement is not fast enough to get us to a good place. So that's the big challenge for all of us.
Thank you, Luís. Okay, I know time is short. Can we take a question from the gentleman in front?
Thank you, Professor, for your very interesting presentation and answers to interesting questions. You've talked about urbanization and the relationship between GDP growth and urbanization, but I'm just wondering, what about rural development? Okay, have you studied how, because you say majority of populations live in urban areas in most developed countries, but you still have very large segments of the population living in rural areas.
Yes.
And and you've got the rural urban migration issues. So is there any thought given to your research where you think, look, there is a limit in terms of urbanization, and there must be efforts to also develop rural areas, rural enterprises, and, you know, in terms of agriculture, for example, food production is going to happen in rural areas. So how do you ensure that there is sufficient development that leads to inclusive development, right? Rural areas, services provided to them, so people are not just all coming to cities, making cities unsustainable. So having rural development as part of making sustainable, inclusive development.
Absolutely, that's a great question. I should say that most of my work, we've been talking about cities and so on, it's easy to think about just the large cities. But in fact, the way all this stuff is studied, you see this even in the scaling studies, is that you look at cities and settlements of all sizes. So you're looking at the low ones too. Now usually most nations, as they collect data, they call a small city different things. It depends on density and what people do. For example, the census of India, which we're waiting for the new one, but from 2011, has, for a city, you have to have a certain density, and you have this weird characteristic that most people should not work in agriculture. So it excludes very small settlements, villages, and so on. So but nevertheless, one is looking at different sizes and the composition and so on. So there are two things to be said about this. I think we don't know the full picture, should be said. But in times of fast urbanization, it means that life in cities has become attractive, particularly for younger people. They're the ones who migrate. And this means that the countryside often gets deprived of young people, so labor that would in the future also be working fields and agriculture. So you start having these demographic imbalances. Over time, in most nations like the United States or Europe and so on, this tends to lead to aging and a certain depopulation of the countryside, which sometimes is okay to some extent, but then also leads to a different structure of property, that people starting, small properties are no longer viable, and then you have larger properties, and you have more industrialized methods of agriculture. So that changes. And then agriculture changes. So not agriculture is the same, but you go from a logic of subsistence, where people are just feeding themselves and their communities, to start producing food to the city and for export. So farming in the United States is almost all an industry for export. So it's no longer what it used to be. It's a different thing. So in that sense, agriculture becomes integrated into the urban system, and you tend to see economic growth, that the rates of economic growth, 3% a year and so on, happen everywhere. So they grow with the city. But they tend to be always subject to industrialization, strong economies of scale, and so it's no longer a nice agriculture of mums and pops and so on. So that transformation is very common for good and bad. There are most countries, most richer countries have put a lot of effort to continue to make the countryside more viable with different effects. So Europe, the United States, now China have strong subsidies to keep people in the countryside living better, investments in infrastructure, agricultural subsidies, and so on. The results have been mixed. Usually it doesn't stabilize the demographics very well. But for example, in Europe, even though it costs us a fortune, it creates very nice produce and cheeses and all kinds of things that actually, so there's a certain balance. Usually the places that have the best balance, where you have quality of life in the countryside, but you have an urban country, are places where the countryside, the urban life, is never very far away from some of the things that are easier to supply in cities. And these things, as a country gets richer, very critically become health provision. So if you're an older person, you want to be in a hospital in 10 minutes, right? You don't want to have a heart attack. So if you live in a rural area, can you do that? Education, kids, school, things like this, and also some recreation. So countries like Switzerland, for example, I know this is a different reality, or Netherlands, they have very good trains and transportation systems. You never more like 20 minutes, half an hour from a city with those facilities, but then you can live in the countryside and have a rural life almost. That's much easier than a country that's very large like the United States or China, where effectively you're very far away from the urban amenities. And then that push and pull becomes much harsher. So that's typically, you want to have the new things that the cities are creating so that your life keeps improving, even if you're in a rural area. And how might you get them becomes a very difficult question. You mentioned economies of scale. It's very hard to have economies of scale in very small settlements, for example, for a hospital and so on. So you end up with very more basic functions, and those sometimes are just not good enough to keep people. But that's the nature of the problem. So I'm answering your question by saying, if you could solve that problem, having people access to all these advanced services, then you could stabilize populations in the countryside. And that a few examples of that.
Thank you. We're running short of time. So I'd like to close off with a retrospective question, Luís. In your Nature article, I think more than a decade ago, right, you called for a unified theory for urban science, right? 15
That's
years.
a bit Jeffrey, but
is it 15 years? Almost 15 years, right?
Yes.
Yeah, 15 years on. Do you feel we are closer to such a unified science of cities? And what pieces of the puzzle do you think are still missing from this?
Well, we'll fight about it, right? But I think so. Again, not just to say, I think so, yeah. I mean, we can explain cities through history, we can explain cities across nations, sure, yes. Now, I think the problem is, like with any science, you see this also in urban science, and it's to be expected. It's much easier to make predictions on the aggregate than in detail, right? So, if you look at the history of physics, you start with the solar system and so on, but it's very hard to predict the material. Even if you think you have the theory, there are details and contextual things and so on. And, in the social sciences, not just, the traditional social science, but you see this a lot in demography and people who study risk and accidents, like insurance and so on. People are very predictable on the aggregate. We're having that discussion. You have data on the aggregate, but you want to predict it more specifically. That means that we have to start predicting detailed human behaviors, and that's hard to do, fortunately. People are different. So there's that question, can we be more precise and explain some of these things, like the difference between neighborhoods or human psychology, some aspects of human psychology, not all of it, but some aspects like what we're showing, depression, and so that's an uncertain thing. But a lot of my work has to do, a lot of my work that I'm doing now has these two, if you will, frontiers. One is to go to more smaller populations. If you understood like the differences in connectivity and the social context, you should be able to do that. So it's the theory of social network, but now you're putting more contextual information. And then I mentioned this a lot today, but just to make it explicit, is the dimension of time, of change, right? So you would like to predict social change and cultural change and economic change. And that dynamics is always harder than statics, right? You also see this in almost every field. And so I think we still don't know, enough. For example, a classical problem is the problem of economic growth. Economists have studied this a lot, and they will tell you that the only thing that can be driving economic growth is knowledge and information. It's not just more resources. People change what they do, the quality of what they do, how they do it, the knowledge that's embedded. But they don't know exactly what this knowledge is and how it's translated into 3% or 2%. Can you predict that number? And so if you had a good theory of all this together, you should be able to predict that number, and predict that number that's different for different people, so that you also see if inequality is getting bigger or smaller, right? People are converging. And the same thing for other rates of change. So those rates of change, we know that typically they're exponential. They're percent numbers like that. They're not absolute numbers. They're always percent numbers. Those numbers are very predictable. The economy is not going to grow by 50% next year, or minus 20%, hopefully. It's going to be, 2 or 3%, a number like that. Who called that number? What is that? So we don't understand how to predict those numbers, though we have some understanding of the process. So I would love to be able, if you could do that, my gosh, you could do so much. I mean, I should say, and I'm giving him credit, not just blaming him, that the Grand Unified title was Jeffrey's. I was a little bit more timid about it, but then it stuck, and nature likes big splashy things, so it stuck. But
Yeah,
it's
we
to
need
his
to have
credit.
Jeffrey here next
Yeah.
time.
If you met him, So, I think maybe we'll finish with this thought, and maybe you can blame me, or maybe it can be inspiring to you. But I think to be a scientist, you have to be an optimist. You have to think that new things can be discovered and understood. If you don't think that, why bother? So you're hearing my optimism. I think there's a little bit of a track record and results in the field that kind of justify that. But there's a bit of a judgment there. But if you're not optimistic that we can discover new things and understand them better, then you probably should not be a researcher, right? Because then there's no way to do that. But some disciplines got there, and they say, no, we cannot understand things better. We only know what Aristotle knew or something. And then why bother? I don't think that's true, of course. I think it's patently non-true. But if you have a certain relative sense of knowledge, that all knowledge is equivalent, there's really no improvements in knowledge, then it's very hard to talk about science and improvements in understanding and so on. I think that's false, but nevertheless, people have these discussions. So I think optimism and the ability to discover is very important. And then if you don't try it, you don't get it. So, some people will discover things if they have that attitude.
Thank you, Luis. With that, I'll call this plenary to a close. I certainly found, the talk we had over the past 2 days very enriching. I hope the audience enjoyed the discussion, right? And thank you, Luis, for this wonderful talk. Thank you, everybody, and have a good evening.
Thank you very much, everyone. Just a quick announcement before you guys head up. The main entrance is actually already locked. So when you guys head down the lift, you guys will have to turn right towards the entrance on the side instead. So just a very, very last bit. Okay. So before we end this evening, we'll really appreciate your feedback via the QR code at the top. And if you guys want to keep a lookout for future public lectures by NUS Cities, take a look at some of these QR codes on the bottom left. And we've got some socials on the bottom right as well. And once again, thank you everyone online and offline in person with us for joining today's lecture. Have a good evening, everyone.
Wait a minute.